In this video, we're going to take a look at how can we find the quadratic equation that certain roots came from. So if we're given roots, what was the quadratic that started from? So for instance, if I take a look at this, if I have roots of 3 plus or minus 2i, there's a couple different things we could do here. I'm going to go over two different methods. First of all, if those are roots, that means that x equals those. X equals 3 plus 2i, and x equals 3 minus 2i. So I have two separate roots there. One of the things I can do is just take a look at one of them. It doesn't matter which one. And I can work backwards from this. In order to get rid of the I need to square it. But what I don't want to do right now is square it in the form that it is, because if I squared both sides, I'd need to make a generic rectangle out of this, and I actually would not get rid of the I. What I'm going to do first of all then is subtract 3 from both sides, and giving me x minus 3 equals 2i. Now I'm going to square both sides. Squaring this over here is going to give me x squared minus 6x plus 9. Squaring the right side, I'm going to get 2 squared, which is 4, and I squared is now negative 1. So now I have x squared minus 6x plus 9 equals a negative 4. Moving the 4 to the other side, I'm going to get x squared minus 6x plus 13 equals 0. And now I can just switch that 0 to a y, and there's my equation. If I use the other root, it does not make a difference, because doing the same steps here, when I square both sides now, I still, on this side, get the same thing right here of x squared minus 6x plus 9. When I square negative 2i, it's the same thing as negative 2i times a negative 2i. So negative 2 times a negative 2 is a positive 4, and again I get I squared, which was the exact same as I got here. And now the same process goes through to give me the equation. So that is one of the methods. A secondary method would be, again, looking at my factors here. If I have a root of x equals 3 plus 2i, and x equals 3 minus 2i, my factors then are going to be x minus 3 minus 2i equals 0. That is now a factor of my quadratic. And I have x minus 3 plus 2i equals 0. That is now another factor. So when you solve a problem that has been factored and you do zero product property, this is essentially what you end up getting. You get both your factors equaling 0. So what I did is I started off with the roots and made them both into equations that equal 0 and found my factors. That will now give me a 3 by 3 generic rectangle that I can now multiply to get my quadratic. So now I just fill the rest in. I have an x squared, a negative 3x, and now this top one is a negative 2ix. Again, a negative 3x here, a positive 9, a positive 6i, 2ix, negative 6i, and this top corner box is going to be a negative 4, negative 2 times positive 2, I squared. So if we take a look at a couple of these, that one is a negative 2ix, and this is a positive 2ix. Those will make 0. And same with the 6i and negative 6i. Those will make a 0, so they zero out. This top box now is a negative 4 I squared. Since I squared is negative 1, it's a negative 4 times a negative 1, which equals a positive 4. So that top box is a positive 4, which means my like terms now equal 13. And I have an x squared minus 6x's plus 13. And that's my equation, which is now the same as what I came up with before. So two different techniques, both of them starting off with the roots.